Hi, welcome to another session of embedded course. So today we will be looking into functions and pointers. I hope in previous session I explained storage classes, qualifiers, structure, union and enums. I hope these are clear. And also I explained the instruction set. So today my main focus will be on functions and pointers. So I will be explaining what all different types of function are and how they are actually used in embedded systems. Similarly, pointers and their use in the embedded system. From that perspective, I will be teaching them. Okay. So let's start. Okay, so let's start with functions. So basically, a function has two part. One is definition, another one is declaration. So what is that? Like a function will perform some activity for a user. Whatever we can write a function to print something or calculate something, right? So if we consider a void function one, and inside we just try to print something. Okay, so this void function is doing a print operation, right? And this is the whole definition of the function. So when there is a body of function involved, then that is called the definition of the function. And if there is only the initial statement, then this is called declaration of the function. Consider declaration as the index of a function, right? Like when you read a book, you have a contents, right, where you can go and check what all things available in this book, and in with the particular name of that chapter, if you go, you get the entire chapter. So this function declaration is acts like an index, and this is the chapter, so where the entire function is defined. So I hope it is clear. So definition is the actual function implementation. This is implementation. Declaration is the prototype of function, means we declare that the function with the same name, return type and argument. Okay, so when we try to do a declaration, we have to just copy the initial starting heading of that function and put a semicolon to it. It should have the same return time, same function name and same arguments. Okay. Okay, now let's see what all different types of functions we are having in embedded, or generally we use in embedded. So first thing is normal functions that are generally being used, and then we have static and inline. So first we focus on normal functions. So normal functions are created and stored in the flash area. So every function when we write, when it will be compiled, then it will be stored in the flash area of the memory. Then calling, when these functions will be called, it will always be called during the runtime. Okay, so and functions are by default, normal functions are by default global, and they can be called into multiple files wherever you want, you can call them. Okay, and this require a stack pointer. Yes, it requires a stack pointer. And cpu overhead means the cpu needs to know from where the function is getting called. So just give you an example. Suppose if you have something in main, and in main you are calling function 1, then what happens in the stack pointer, this main will be there, then inside main the function 1 will be stored. So this stack pointer will be keeping track of this function from where it is calling, then again it has to return back to the main. Okay, so this creates an extra overhead for the cpu. The cpu has to do this extra work to keep track of this function 1. Okay, so that is here written. So let's look into the code. So so here I have created one small function, code file as function. Inside that I have declared three types of function. First is normal function, then is static function, and then there is static inline function. So I will be showing you what all effects are there. So if I just run the first function, okay, and just run, okay, I will run it. So it created exe file, and I will run it. So after running the exe, you can see function, this is function 1 2 3. So inside function 1, I am calling all the other function 2 3. So these all are called. So from here one thing is clear, that this function, this is called a general function or a normal function. So as this function doesn't have any extra qualifiers, like it doesn't have any keyword like static or inline attached to it, it is a normal function and it is global in nature. We can use this function in any .c file if we include the .h file associated with it. And whenever we attach extra qualifiers like static or inline, it become a static function or a static inline function. Okay, so let's now understand the other functions. So I hope it is clear. Like it is called during the runtime, its scope is global. It requires a stack pointer to store the function, and the CPU has an overhead. Means the CPU also needs to track from where the function is called. So let's understand one more important thing is that whenever we write a function, okay, in the C file, whatever is the return type, and then what happen is when this function is compiled, then this entire function code will go and sit at a specific memory location in the flash. So what happens whenever in during the runtime the CPU encounters a function call, then it will go to its specific memory location. From there it will copy the content of the function to the RAM, and it will execute it. So every time the function is executed, it is copied to RAM, and the CPU has to know from which location this function is called, and it has to create the local variables associated with that function, and then release that RAM area for the next use case. So for that purpose only, the CPU has to maintain an extra overhead to do this all operation. That's why a CPU overhead is involved. Okay. Okay, now let's look into the static function. So what is static? The static actually is a normal function, just we use a keyword static in front of it. So it limits the scope of the function, rest all things remain same. It is also created in Flash, called during the runtime, but it becomes local in nature. Means if we write a function in function.c file, then that function cannot be called in another function, let's say function2.c file. In that file it cannot be called, you cannot call. This function has to be used in the same C file. So it the static keywords make it local to that. So this is used in order to make the function like a private kind of thing in C. Like you don't want to give um, it out to other users, and then you want to restrict its scope. That's it. Okay, and one more important thing is like suppose you have written a function like sum. So where you are using the sum to calculate the sum of two integer type of variable. If you use a static in front of it, you can use it in the same C page, but in the name C, in the other C file, you can use the same function. You can create a function with the same name like sum int of maybe this sum is for float. So you can use the same function name in the another C file. So this will not create any double definition of the same function. So for that also the static keyword is used, where you want to have multiple definition of same kind of function with same kind of function name. So yeah, so let's look into the code part. Okay, before going into that, it also requires a stack pointer and also creates a overhead because it is placed into the flash area. So whenever there is a flash involves, an overhead is involved. Okay, we will be trying to use the static function in we will try to call the static function. Let's call function 2 instead of function 1. If I just give function 2 and try to build the code, see what it is giving. It is giving a warning that function to use but never defined, void static function 2. So function 2 you cannot use because function 2 is a static and its scope is limited to only functions.c file. You cannot use the function outside the scope. So that's the main part to be explained here. Okay, now let's look into the inline functions. So first of all, inline functions are not stored in the flash. So what happens where it is stored, right? So this is something like it will be called during compilation, and it will be replaced or created if the function is called. So if that inline function is never called, then that function will not be created and will not be kept into any location. And this function is like, suppose you have written a function like static inline function, some function, and inside that you are printing some variable, and you are calling the function inside the main function. Okay, so during compilation what will happen, the compiler will remove this function and it will copy the content of this function here. Okay, the definition will be copied directly, and so the stack pointer doesn't have to maintain anything. So it will be always in the main file, and there will be no CPU overhead, as this function is never created in the RAM. It is just during compilation time, it the content of the function will be directly copied to the place from where it is called. It's that simple, it will be replaced. Okay, let's have an example. Like, we have a function static inline shift, and here you want to give the bit you want to shift, and inside that function, it is like a will always be shifted 5 bits, and it will be copied to a. Okay, and like that, and maybe return a, and it's an integer type of static inline function. So you are just shifting a bit. Now if you see, if you don't create an inline function, you create a normal function, then what happens? For shifting just a bit, you have to involve a stack pointer, you have to involve the CPU. Instead of that, to do just a one single line of code, you can just use this static inline function keyword, and it will just copy the entire thing. Suppose in the main, we are first calling this shift 5. Okay, now instead of this, it will be removed, and instead of this, it will become like 5 equals to 5 less less shift, like this. So it just removes the entire requirement of having the overhead and CPU, in case you can have just the single one line replaced here. So this is the advantage of having a static inline function. So let's look into the code part. So like I said, if I try to build with a static inline function called, it again gives an error, the implicit declaration of function 3 undefined reference. Okay, because it's a static inline function and we cannot build the function, it can only be utilized in the same code part. Okay, so this is a website, Compiler Explorer. You can go and you can generate what will be the output of the different functions, to see what is the final output or what is the preprocessor output. So let's see what happens if we just play with these keywords. Okay, so I have first written a void function. Okay, and if I don't want to call this function, so when I written this void function, so this function is defined here in a portion in the memory location, and then in the main, this function one is called. This is simple, right? Now I will just remove the calling of the function. So you see, only the calling is removed, but the function still is created in the flash area, right? Now let's make this function as static. So if I make the function as static, still it is getting created in the flash area. And if I remove the calling of the function, then also it is getting created in the flash area. So in that way, the static and the normal functions are same. Only the thing is, static function is localized and it cannot be used outside. You can also use the same function name in other files. It will not give any error. Okay. Now let's use the static inline keyword and see the difference. Now you see that when I have given the inline function, this function itself has not been created because I am not calling the function. So once I call the function, then this is created, and during the runtime, what will happen? This code get copied here in place of this function one, and it will be executed. So this is the whole scenario. If I just remove the calling, then this static inline function will never be created. It is only created when the compiler sees, okay, this function is being called in one place, then it will create the function and copy the content in that location. Okay, so I hope this clears your concept about normal function, static function, and static inline function. Okay, so let's start with pointers. So first thing, pointers are the most important in embedded. So there is no such embedded coding where pointers are not used. It is very important aspect from embedded point of view. So have your attention and focus on this. So what are pointers? Pointers are something that points to the address of variable or function. Okay, it's simple that any variable, if I say int a equals to 10, so what happens? A will be given an address. So a will be given an address, let's say 0x020000 in RAM, or in flash, and at this address a will be placed. And if I say pointer, a variable that is pointing to this address will be called a pointer. Okay, so first thing, how we define a pointer? We define a pointer like, first is the data type of the type of pointer we want to use, then a asterisk, and then the name of the pointer. Okay, this is the definition of a pointer. And this type def defines what kind of pointer address it can point to. Okay, so remember, there can be function pointer and a data pointer. A pointer always points towards the memory location. So this ptr, when you assign, how we assign the address of a variable, so we assign is that ptr equals to ampersand of a, so where ampersand takes the address of the a and sends it. So if you just print ptr, it will print out this address, this 0x0200. Okay, now when we want to get the value at this address, then we again has to use the asterisk in front of this pointer variable, and then this will finally point out towards this variable. Okay, now let's see the pointers. So there are basically two types, one is data pointer and one is function pointer. So first we will see and understand the normal pointer in the code. Okay, okay, so here I have written a small function to demonstrate the different condition of a pointers. So I have taken one structure, I have defined one structure, and I have declared one variable d1 that is of this structure data type, and then I have declared an int a type. So when I have updated the values of the structure type variable d1. Now I created two pointer. One is integer type pointer, one is the structure type pointer, and in both of them I have given the value ampersand a and ampersand d1. So when I am printing the value of the integer type pointer, and I am trying to get the value what it is there. So if I run it, you can see I am getting the value of all of them. So first the integer is 10, I am getting 10. Then the structure is having the value as 88 and b, I am getting 88 and b. Just notice one thing, whenever you are having a structure pointer, then you don't need to put this asterisk to fetch the data. You have to use this symbol, that is an dash followed by an arrow. So this will fetch the data of that particular element of that structure. So by using that, we can fetch the value of that structure. Now if we want to see the address of this a, then I will just remove the asterisk and print it. So this is the address of a, that is this address of this a, where this 10 is located. Now to give you a better look, so I will print it in hexadecimal. So this is the actual address in the hexadecimal where it is stored, this a is created and stored. So this is the concept of the pointer. So pointers always points to the address of that particular variable. To access that variable, you need to use the asterisk. If you are assigning it to a structure or union, then to access the value of its individual elements, you need to use this arrow dash followed by arrow symbol, and you can access it. So next important thing is null pointer. So just remember, a null pointer is pointing towards the location that is 0 and its value is 0. That the location where it is pointing to is 0, and at that location there is no value, so it is null. And while null pointer is used to initialize a pointer variable so that it doesn't point to a wrong direction. To avoid, like if I say int star ptr, so this ptr should not point to some other memory location, some garbage memory location, so that when I try to do some operation, it should not go and change something else in my code. So to avoid that, I will always assign this with a null pointer. So this null will ensure that it is always pointing to some void point where, and I am specifying that it should point to only specifically null, and when I want to initialize this pointer, it will get initialized to that particular pointer location. Now next thing, what is void pointers? So this is one more important thing. Void pointers are used when we don't know the data type of incoming data. So what does it mean? Now suppose void pointers are basically the pointers which can be converted into any other type of pointer. It is said as void. Now suppose you want to write a function like to copy a memory, copy data. So you want to copy data is a function. Now you don't know what type of data will be coming. It can be a string type data, it can be a integer type data. That time you can use the void pointer. So whatever you get, you convert it to void pointer and then you utilize it. Or suppose you just want to do some increment operation, so whatever comes you want to convert it into integer type of pointer and then go ahead. For that you can use a void pointer. So let's look into an example. Okay, now I have written a small code to demonstrate you what is the requirement of a void pointer. So first let's look into the first function. So I have you getting creating one function with a void pointer type argument, and this whatever is the pointer that I am receiving, that I will be converting into uint and printing the value at that location. Now in the second function, I am specifically using an uint type of pointer, uint type of void pointer in the uint type of pointer in the argument, and whatever data you are sending, that has to be in uint 8 or you will have some issues. So if I send a character type of data in function 1, then see what happens. It prints the ASCII value of this character. Now if I send A instead of B, what happens? It prints the value of A. So since this is a void pointer, it doesn't do anything, it doesn't require any type conversion. You can directly send the address of any variable and it will be internally taken care. So void pointer is helpful in the scenario where we don't know what kind of input or variable we are going to receive. Now if the same thing we do with the function number 2, let's see what happens. Since it's a uint, it still works. See here, still it gives some exceptions and warnings, but it still works. Okay, now if you try to pass B, then see what happens. So if you try to pass B, then it takes. Why it takes? Because uint 8 and character are same. So maybe if I just change it to integer, then you will see what will be the actual issue. Actually uint 8 and character both are the same size, like all are 1 byte, so that is not creating any issue. So if I take int type of pointer and I passed an a b to it, so it is giving some wrong values for this pointer, because at this time the typecasting issues will be coming. So that's why a void pointer is most preferred in this scenarios. Okay, now the next most important thing is function pointers. So this is used to point to a function, and we need to understand why we need a function pointers. We could have called the function from any point, right? And we can declare a global function and call it, but why we specifically need a function pointer? Let's understand that. So first thing, how to declare a function pointer. So if I had a function like void function 1, and inside we don't have I have an argument, let's say int a, then the function pointer should also consist of these specific arguments. So we have to declare the return type void, then in a bracket we have to declare the function pointer, and outside we have to declare the argument it is having. So this is how a function pointer is declared. And here fptr can be equal to f function pointer 1 address. So this is how a function pointer is assigned. Okay, so let's see in the code. Okay, so here we can see why we actually require a function pointer. Okay, so basically if we see that this is a structure, so this we want to have a generic version of an object. It can be a square or a circle. Okay, in that we need to have in that structure the either the value of that square sides or the value of the radius. So it can be anything, a square or a circle. And we also need to calculate the area of that corresponding object. It can be the area of a square or an object. So here we one thing is confirmed, the value will be integer type. So we define integer type, and the object that we will be creating, the area of the object will also give us an integer value. But we don't know what kind of area we need to calculate. That's why we create a function pointer with the name area, and whatever the user required to give that area function, it can be of a square, or I can just copy and paste it and then give a name as area of a circle. Let's say we give a circle, and same thing will happen, just we need to multiply once with 3.14, right? and return the value. So you see here what is happening is we can declare any kind of function and pass it to the function pointer, and the entire code will run as it is. Just the type of function we want to implement on that object will change. So now if I run this, you see the area will be calculated, that is area is 25. And now just I will update this function, okay, and run it. Now see the area changed to 78 because the function which I am giving to the function pointer, now this function pointer is pointing to the function which is calculating the area of the circle. And if I just change this function pointer where it is pointing to, now it will be pointing to the area of the square. So I hope this is clear. So this is how the function pointers are used. Okay, so I hope today function, normal, static, and inline are created. Then data pointers and function pointers are created. So from next day onwards, it will be an interesting session with actual coding in embedded. So I will be going through the code and all with actual board and firmware development. Okay. So thank you everyone for watching my videos. Please subscribe to my channel and like the videos and share with your friends. So in this embedded course, so many of you guys are contacting me for embedded course or coaching. So I will be doing an embedded coaching kind of thing. So those who are interested can contact me on LinkedIn. Okay. So thank you and have a nice day.